everyone, welcome back to your Math Hub channel. I hope you're all doing fantastic. Today we have an exciting video lined up for you. We're diving deep into the world of quadratic equation. Now, if you're a student who recently tackled this in class, you are in for a treat. We'll be going over some fantastic practices that will help you ace those quadratic questions. Before we get started, let me quickly mention that the content we're covering today is not just for my students, it's for anyone out there who wants to enhance their understanding of quadratic equation. So whether you're a student, a teacher, or just someone who loves math, this video is for you. Now let's refresh our memories. Quadratic equations are a crucial part of algebra, and they often appear in various real-world applications. Remember, a quadratic equation is in the form of ax squared plus bx plus c equals to 0. So you can watch my previous videos on different methods to solve the quadratic equation. In my recent class, actually in one of my classes in Math 262, I gave my student a quiz on quadratic equation and I was blown away by their performance. To everyone who participated, great job. If you haven't taken the quiz yet or you're not sure about the answers, you can watch this video to get the correct answer. Now let's deal with the first question. The first question is asking you to solve the quadratic equation. So quadratic equation, no matter what method you use, the question doesn't ask you for doesn't mention any specific method. So it's up to you what method to use. But remember again, this is the general form, quadratic, so the biggest power is 2. Let's start with this example. So here, the first example you have, the coefficient of x is 0, so it's like you can easily ignore it. If I want to find the coefficient a is -1, b is 0, and c is 41, you can use the quadratic formula, or you can use any other method. For this one, I'm going to use this method. -1 times x squared is negative x squared, and then I move 49 to the other side, which would be -49. So now I could say both sides can be divided by -1, so I have x squared equals 49. The answer is plus and minus 7. This is your final answer. Okay, remember guys, you can solve this one from many different methods. Let me show you another method. Minus x squared plus 49, it's equal to, I just rearrange it, write it like this. And remember, this is the difference of two squares. So you can also write it like this. And then this one would be equal to 0. Remember, when two parentheses or two brackets are equal to 0, any of those can be, potential answer. So potential 0. So here x plus 7 is 0, or 7 minus x is 0. And from here, x would be -7, and from the second one, x would be plus 7. So I solved this equation from two methods. It's up to you if you want to use these two or any other. Let's say you have the coefficient lined up here. You can use the quadratic formula. The second one here, I have 4x squared plus 10x minus 24. So I line up the coefficient. A is 4, B is 10, C is -24. But let me give you a tip for actually solving the quadratic equation. Whenever you want to solve a quadratic equation using the quadratic formula, remember to move everything into one side. So everything would be one side, and the other side of the equal sign would be equal to 0. So here I have all the coefficients. What I can do, I can either factorize it and solve by factorization, or I can use any other method. Remember here, if I want to factorize it, this is the repeating term, so I put the square root, and then I'm looking for two numbers, which I add them, I get 5, and if I multiply them, I get -24. So the two numbers would be 8 and negative 3. When these two are multiplied together and the answer is 0, that means any of those can be a potential answer. So if the first bracket is 0, we get x is equal to negative 4. And if the second bracket is 0, then we get x is equal to 3 over 2. So now you have two answers, and that is what you expected because it's a quadratic equation. Let's say some of you prefer to use the quadratic formula. So let's use the quadratic formula and see if we will get the same answer. So here, negative b plus and minus b squared minus 4 times ac, right? And then here 2 times a. Now let's simplify and see what we get here. Negative 10 plus and minus. So under the square root, it's 100. So it's 16 multiplied by 24 plus 100. So the answer would be 484, and then the square root would be 22, okay? So here I have 8. So if I want to simplify it, one answer would be negative 10 plus 22 divided by 8. The other one would be negative 10 minus negative 22 divided by 10. So from the second one, I get negative 4. From the first one, I get 12 divided by 8, which is after simplification by 4, it would be 3 divided by 2. Okay, third one. Again, I have a quadratic equation perfectly lined up from the biggest power to the lowest power. Here, a is 1, b is 1, c is negative 2. So here, you can use any of the methods as I just mentioned. I prefer to use factorization. So x, I'm looking for two numbers. If I add them, I get 1. If I multiply them, I get negative 2. So if I add them, I get 1. If I multiply them, I get negative 2. So if these two brackets are multiplied by one another and the answer is 0, that means any of these can be a potential answer. So if x plus 2 is a potential 0, that means x is negative 2. And then from the second one, x minus 1 is 0. So x could be plus 1. So again, you got two solutions, you got two roots, and this is what you expected because it's a quadratic equation. No matter what method you use, either if you want to use the quadratic formula to find the solutions, you should still get exactly the same values, okay? So that was question 1. Moving on to this next question, it's asking you about the nature of the roots based on the discriminant value. Okay, now, first thing first, what's the discriminant, right? So remember, guys, when we said like this is a quadratic equation, plus c is equal to 0, and we had this formula to find the two roots. We got it from this value, b squared formula, right? 2a. So here, this under the square root, this thing, b squared minus 4ac, b squared minus 4ac, it's called the discriminant, right? This is very important, and it gives us a hint. It gives us an idea of the nature of the roots without actually finding the exact roots. So b squared minus 4 times ac, for a quadratic equation, it's called the discriminant, and most of the time they use this symbol like a triangle to show it, okay? So as I just mentioned before, based on the value of the discriminant, right? So let me write it here. So based on this, either your discriminant can be greater than 0, equal to 0, or negative, right? If it's greater than 0, you would have two different real roots, okay? Like the ones that we did, right? Like we did 3 questions, right? But if it's equal to 0, you would have two identical real roots, right? You still have two roots, but the two roots are similar, are identical. But when the discriminant is less than 0, that means under the square root, it's negative. Do you know what happens? Here, we would say that we don't have any real roots, but don't worry. Because later on, when you get to know about complex numbers, you will see that we will have two complex conjugate roots. Okay, remember guys, this is the three different situations we will have: greater than 0, equal to 0, and less than 0. These are the values of your discriminant. And in this question, the question is asking you just find the nature of the roots. The question is not asking you to solve all the equation and find the exact value. It's only asking you to find the nature of the root. So the first one is x squared plus 9x plus 14 equal to 0. Let's start solving by this. So here a is 1, b is 9, c is 14. So if I want to find the discriminants, b squared minus 4 times a C. So that would be 81, right? 81 minus 4 times 14, 56. So it is definitely greater than 0. It is actually 25. So according to this thing, we should have two different real roots, right? Two different real roots. And please remember, whenever you're writing down, you have to specify that there are two roots, they are different, and they are real numbers. Okay, what I want to do now, I just want to solve this one and find the exact root and show you what the two roots are, and you will see that they are different. So if I start by factorizing again, I'm looking for two numbers, add them, we get 9, multiply them, we get 14. So you can see from here, one of your roots is -2 and the other one is -7. You exactly have two roots, different and real numbers. Let's move on to the next question. X squared minus 7x plus 10. So here again, the question is asking you about the nature of the roots. So first of all, you have to identify a, b, c. So the discriminant is b squared minus 4 times ac. So the discriminant is 9, which is greater than 0. So definitely you would have two different real roots, right? And again, if you try to solve it, this one is also an easy one. I solved by factorization. Two numbers, you add them, you get -7. You multiply them, you get 10. So from the first one, the solution would be either 5. From the second one, it would be 2. So as you can see here, you have two perfect roots which are different and they are real numbers. Let me clarify here. The question is not asking you to solve the equations and get the perfect answer or roots. It's just asking you to discuss about the nature of the roots based on the discriminant. The only reason why I solved it, I just wanted to show you that, just by calculating the discriminant, you would have an idea. It's just for clarification, for extra explanation. Okay, I have another two questions here. Again, A is 3, B is -10, and C is 3. So let's form the discriminant. B squared minus 4 times AC. So 100 minus 12 times 3, 36. So your discriminant 64 greater than 0. So you would have two different real roots. Okay, perfect here. Now, the last questions for this video is that A is 1, B is 1, C is 1, and then discriminant is B squared minus 4 times AC. As you can see here, the discriminant is greater than 0, so you would say that there are no real roots. Remember, guys, no real roots. Back to these three different categories, you would see that when the discriminant is less than 0, there are no real roots. When you learn about complex number, you will see that there would be two roots, but of complex numbers, imaginary. Okay, so and before we wrap up, please don't forget to hit that subscribe button below and check out my other videos. We've got a lot of exciting math content and I'd love for you to be part of our math loving community. That's it for today's video on mastering quadratic equation and doing some practice on the nature of the roots of quadratic equation. I hope you find these practices helpful. Remember, math is all about practice. So keep working on those problems and you will be acing quadratic equations like a champion. Thanks for joining me today and I'll catch you in the next video. Happy mathing!